you look up in the night sky, what do you see? For centuries, this expanse of shimmering light has encouraged our sense of wonder, begged our exploration, and illuminated even the darkest nights. How amazing, then, that millions of points of light like these could be harnessed to allow machines to visualize the physical world. As mind-bending as it seems, that's exactly what's at work in LiDAR technology. While self-driving vehicles don't have optic nerves, they do have complex systems of hardware and software that help give them the gift of sight. At the center of that system, LiDAR.
LiDAR is short for light detection and ranging. It basically means using light to detect the range or distance to an object. A LiDAR sensor shoots light out. That light bounces off of a target. Some of that light reflects back towards your sensor. That light is collected, and that received light is used to determine how far an object is away.
Visualized LiDAR data is called a point cloud, and these dotted images create highly detailed, spatially accurate representations of the world around Aurora's autonomous vehicles.
There's the long-range LiDAR system, which is the first light LiDAR system that we develop here internally at Aurora. So what that enables is really long-range measurement detection capabilities. So where traditional LiDAR systems are typically spec'd out to 200 meters, first light LiDAR can see 300 meters and beyond. Bright objects we can see all the way out to 500 meters, and in the future we'll be able to see even farther.
That's a sensing range longer than the Eiffel Tower is tall, and roughly the length of the Empire State Building from street level to the tip of its spire. The furthest edge of that range is a staggering 5 football fields away from the sensor, but range is only part of it.
With coherent LiDAR, you have what we call Doppler sensitivity. Doppler is equal to velocity, so you not only know for every measurement point that you make in your scene how far the object is away, you actually know how fast it's moving, either towards or away from you.
A sensing distance more than double that of many currently available LiDAR units, and a perception system that can measure the speed of other actors on and around the road, regardless of size, is one reason why the Aurora driver can operate confidently at highway speeds.
They always say, don't drive faster than your headlights can see. It's kind of the same idea, right? Is that the further out you can see with a LiDAR system, the sooner the AV system can make a decision on what to do. The sooner you have that information, which is directly translatable to how far a LiDAR system can see, the sooner the truck knows what it needs to do, and just the safer the overall vehicle will be. If you revert that whole thing, what it really means is the truck can drive faster and still make safe maneuvers.
LiDAR and the products it supports continues to evolve. With that comes the question of scalability and how to make first light LiDAR smaller, more cost efficient, and easier to produce and assemble to meet the growing demand. The answer? Silicon photonics.
Several discrete parts are now contained and confined on a single chip. An amplifier that we may use today is maybe the size of a deck of cards, but in a photonics integrated circuit, it's the size of a speck of sand. So for example, you can get a laser, and you can get a modulator, and you can get an optical amplifier, which today are all discrete parts. In the future, with a photonics integrated circuit, all those 3 pieces are all contained on the same chip, where you have no interconnections whatsoever. Photonics integrated circuits are, a key enabling technology to decrease the form factor, make it as small as possible, make it as cheap as possible, and ultimately very, very manufacturable, where they snap together and you can make thousands of these things a month.
LiDAR is a powerful tool, and just like looking up at the night sky, it inspires questions of what is possible. With First Light LiDAR leading the autonomous revolution, Aurora is poised to see the future.
Isn't it funny how day by day nothing seems to happen? But when you look back, everything is different. That's the story of Tara. Volvo has always been on a journey, always evolving. Sometimes small steps are taken, sometimes big leaps. With Tara, we understood. It's time to start something completely new and trust in the magic of beginnings. To try new things and not be afraid of failing. A group of talented engineers and designers brought our ideas to the table, supported them, and challenged them. After a while, the clouds parted and we could see where we were going. As our clarity grew, so did our confidence in this radical new solution. With collaboration and energy, our visions quickly came to life. This isn't just new technology. It's a whole new way of doing things. As cool as the TA-15 autonomous electric hauler is, Tara is not only about individual machines, but a whole transport ecosystem that offers greater safety, improved productivity, much lower emissions, and a lower total cost of ownership. We failed at plenty, but we also learned important lessons along the way. As Albert Einstein once said, a person who never made a mistake never tried anything new. Welcome to the future. This is the story of Tara.